Good morning to one and all present here. Today I am going to present here facilitating topics digital electronics, the language of the modern world. Every smartphone, computer, smart TV, and communication systems around us work because of digital electronics. And this presentation we will explore how digital electronics evaluated and why it plays such an important role in modern technologies. From analog to digital, this is the big shift. Before digital system, most electronic device used analog signals. Analog signals are continuous and can take any value within a range. For example, the movement of speedometer needle is analog because it changes smoothly. But in digital signal, on the other hand, use only two states. One is 0 and another one is 1. These discrete value make digital system more accurate and less affected by noise. So, digital technology become popular because it allows information to be copied, stored and transmitted without losing quality. This shift from analog to digital laid the foundation for modern computing and communication system. The brief history of evolution of logic. The journey of digital electronics began in the 1930s with vacuum tubes. These devices were large, consumed a lot of power and generated significant heat. A major breakthrough came in 1947 when the transistor was invented at Bell Lab. Transistors were smaller, faster and more reliable than vacuum tube. During the 1960s to 1970s, integrated circuits IC were developed, allowing thousands and later millions of transistors to be placed on a single chips. Today, modern processor contain billions of transistors on a tiny silicon chip, powering everything from smartphone to satellites. The backbone of computing, it's a binary logic. The foundation of digital electronics, binary logic. Understand two states. First one is the 0, it representing low voltage, and 1 representing high voltage. Every piece of information, whether it is text, image, video or sound, is ultimately represented using combination of zeros and ones. The mathematical framework behind this system is called Boolean algebra, developed by George Boole. Boolean algebra was logically operations such as and or not, which forms the basic of all digital decision making process. Meet the building blocks, and the NOT gate, it reverses the input. Input 0 means output 1 and the input 1 means output 0. AND gate, an AND gate produces an output of 1 only when all the inputs are 1. It is commonly used for conditional operations. And OR gates, an OR gate produces an output of 1 if at least one input is 1. It helps in combining signal from different source. Complex digital systems such as processor, memory units and controllers are built using combination of these simple logic gates. Combinational versus sequential logic circuits. Digital circuits can be classified into two major systems. First one is the combinational logic. The output depends only on the present inputs. Example, adder, multiplexers and encoders. Sequential logic circuits, its output depends on both present inputs and previous state. These circuits have memory elements. For example, counter, register and flip-flops. Sequential logic circuit is essential for storing and processing information over the time. The power of miniaturization. One of the greatest achievement of digital electronics is miniaturization. The Intel 4004 microprocessor introduced in 1971 contained about 2300 transistors. Today, advanced processor contain more than 100 billion transistors on a chip that can fit on your fingertip. This incredible growth follows Moore's laws, which states that transistor density roughly doubles every 2 years. Miniaturization has made a device smaller, faster, more power and energy efficient. Why digital rules everything? First one is the digital electronics dominates modern technology for several reasons. So digital systems are resistant to interfacing and noise and easily store the data and retrieving accurately without degradation. The same hardware can perform multiple tasks simplified by changing software. And digital electronics is present in almost every aspect of modern life. Smartphone, laptops, smart TV and factory automation, robotics, process control systems and navigation system, radar system, communication networks, and everyday life we using the digital electronics for smartwatches, home automation, IoT device. The digital technology content to transform the world around us. The future, our role in digital means VLSI technology. VLSI enables millions and billions of transistors to be integrated into a single chip, making device more powerful and efficient. And field programmable gate array, that is FPGA, allows engineers to create custom hardware design that can be reconfigured as needs. And it used in the artificial intelligence, machine learning, quantum computing, 5G and 6G communication also. As a future engineer, you have the opportunity to design innovative circuits and systems that will shape tomorrow's technology. So to conclude, that digital electronics is the foundation of modern technologies for binary logic and logic gates to advanced processor and AI systems. So thank you for watching.